Hello, good day everyone. Welcome to Auto Guide Math Class, the platform where we give the best of maths method and clarify most of misconception in mathematics in a simple terms. Today, in this video, we would like to walk you through the concept of inequality. It can be said to be an opposite of equality. When there is equality, there is balancing in both sides. When there is equality, then you talk of balancing. That is why in our primary school, when they are explaining the equality sign, so they talk about balancing of both sides. So whatever you put here, you must also put it here. So whatever is here, whatever weight you attach here, you must also attach it here. So this is the word equality. This is what is explanation of equality. If this place is 5, here must be 5. So if I add 2 here, I will also add 2 here to balance it up. That's the word equality. That's how equality works. Well, when you talk of inequality, about so whatever is here, whatever weight you attach here, you must also attach it here. So this is the word equality. This is what is explanation of equality. If this place is 5, here must be 5. So if I add 2 here, I will also add 2 here to balance it up. That's the word equality. That's how equality works. Well, when you talk of inequality, the concept of inequality is about you have to remember these 4 operation, which is this 4 operation of this less than equals to, or we say greater than equals to, strictly greater than, strictly less than equals to, then strictly greater than or equals to. So we talk of less than equals to, greater than or equals to, or the something is strictly less than, or we talk of greater than. So these 4 operation is attributed to or are attributed to inequality. So it now depends on where you are reading for. I always advise students to read from the unknown. So for example, if I have x is less than 5, the pointed part, this pointed part, wherever letter that is there is less. X is less than 5. Whenever I said x is less than 5, it simply means x is strictly less than 5. That means s is not equals to 5. That means x is strictly less than 5. That means 5 is not part of the, so any number that is less than 5. So I can say 4.99999 is less than 5. Right? Say 4.9999 is less than 5. So this is correct, right? So, but it's not 5. So that means if anything is less than 5, that it will work from 4 if those numbers are integers. So when we talk of integer, we talk of both positive or negative whole numbers. So if I consider only whole numbers, we say that the whole number, they are 4, 3, 2, 1, 0, -1, -0, all this continuously, -3, -4, like that. They are all less than 5. Right? So this is how you say the number is less than 5. But in between two integers like 3 and 4, there are infinitely many numbers, many fractions, or many decimal, like 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.88, 999, all of these things, until you get to 4, 4.5, 4.4, 4.1, until you, but it will never be 5. But any number, both decimal and original, they are less than 5. So also, when also say that number is greater than 5, that means you are reading from here, you must read from the letter s is greater. See the wider part, where the wider part is open to is greater. X is greater than 5. So s greater than 5, it means x is strictly greater than 5. That means f can never be 5, but any number that is more than 5. So we can start from 5.1, 5.2, 5.3, 5.4, 5.5 if it must be decimal. But if they are all integer, the one I put here, they are integers. If they are described that those numbers must be integers, the integers that are greater than 5, they are what? 6, 7, 8, 9, 10, 11, 12, 13, 14 to what? To infinity. So they are greater than 5. That you can see the dot show that what? It has no end. So this is what is referred to as what? A number that is greater than 5. But here, let's come to this. When you say x is less than or equal to 5, two things happen there. X is less than 5, and the same x is also equals to 5. That is, these two operation were combined to what x is less than or equal to, you see, to this symbol. So that means there is a combination of two operation here, less than and it's also equal. So if the number must be less than, we treated that one before, and it can also be equal to 5. That means it will start from 5 downward. It will start from 5 downward, less than 5. So it will start from 5, then it will go downward like this, from 5 downward. That means the number will start from 5. That means 5 is part of the option. So that's why you see 5, 4, 3, 2, minus 1, 1, 0, minus 1, minus 2, minus 3, minus 4, minus 5. It is continuously like that. So you see dot, 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 dot before this number. That is continuous. So that's x is less than or greater than 5. The same thing, so I mean minus this dot, dot, dot. So if it's not there before, minus 2, minus 1, 0, 1, 2, 3, 4, 5. 5, if 5, so to stop at 5 and it's going to close at 5. So that means they are integers that are less than or equals to 5. Now, if you talk of x is greater than or equals to 5, that's show that x will actually start from 5, then 6, 7, 8, 9, 10, and so on. So those numbers will continue until what? To the final. But the bottom line is that it must start from what? From 5, whenever there's equality sign at time. But if there's no equality sign, it will start from a number greater than 5, actually, which is 6. So that means if it's an integer, this is their integer greater than 5. So there are other numbers that are greater than 5 here, which is 5.1, 5.2, in between 5 and 6, 5.1, 5.2, all the decimal, they are in between. So there are infinitely many decimal numbers in between 5 and 6. At the same time, 6 and 7 are also. So they are greater than 5. So that's that. Then inequality expression can also be represented on number line as follows. So this number that I've just discussed, that example, can be represented using number line. A number line is a line that shows that differentiate or show part of positive and negative integers. So we show positive and negative integers expressed some number. So mostly positive. So the positive are this side, then the negative are going to this side. So starting while the 0 is at the center. So those positive and negative number, they are all number line, including fraction and other things in between. So they are representing number line. So those fractions are captured in between the gap. So in between the gap of the integers, so we have many fractions or rational number in between. So these are what is called integer. So when you are representing a number s greater than 5 in number line, so you represent number. This is very important. This line, draw line, then the 0 is very important. This 0, if there's no other number there, this 0 is very important. That show that what this part is positive and this part is negative. So whatever go from here is positive, whatever go toward this place is going to negative side. Now, is when you show the 0, then you go to where you have 5, put the 5, then extend it, then you extend it and put line, then you draw it to this point. And there are also other representation. You can see some textbook, you see a representation like this. Where you see 0 at the center. At this point where you see 5, so that 5, this part will be shaded, or you see the thick line and you see the arrow like this along the line. So but this one is better used to represent the number line. So you see at that point it's unshaded. When it is strictly less than, strictly greater than, it's unshaded. But when it is greater than, the arrow will go to the right. When it is less than, the arrow will go to the left. Can you see at the same point, that 0 up here will not be shaded because there's no equality sign here. So if it's not shaded, you have to come to the left to show less. Why greater will go to the right. So for equality sign, x is greater than or equals to 5. When you draw the line at that point of 5, you're going to shade the point, and because it is greater than 5, you are going from there, you move to the right. That means 5, this shading means 5 is part of the solution. So x is less than or equals to 5. S is less than or equals to 5. So from that 5, number is less than. So and you have to shade it to signify that what the the point, which is 5 itself, is part of the solution of the number that are less than 5 or equals to 5. That means start from 5 downward. So the shading, but this open part means it's not 5 is not included. The open should be called it's open. The 5 is not included. There are some rules of inequality that you that we must take note of. There are some rules of inequality that you must take note of. That is the first rule of inequality, which is rules of inequality, is like in the linear equation. Unlike like we have it in the linear equation, it also works like linear equation. Whenever a number crosses inequality operation, the sign operation, the sign of that number, the operation of that number will change. That means, for example, if I have x plus 5 and I have less than 8, for example, you see, if this you are collecting like 10, that means x will have to cross to the other side, right? So you are balancing s, or some people will add something that can remove x here, which is plus 1. So if I move that as s less than 8, so this must cross to the other side. The plus sign here will turn to what? The negative sign, like the way we have it in inequality, inequality sign. So it's also applicable in an inequality. So s will be less than 3. So whenever a number crosses inequality operation, the sign of that number will change. If it is plus, it's going to change to negative. If it is negative, it's going to change to plus. So that's just the simple operation, the first rule of inequality. It also like the way we have it in the equality sign. All right. So another one is this. For example, I have y minus 8 greater than equals to 5. You see, this minus 8 will cross inequality sign. You have s greater than 5. When this one crosses inequality sign, it becomes plus 8. So you have y is greater than equals to 13. All right. So these are the rules, the first rules of inequality. Second rules of the inequality is the most popular part of inequality that is very unique, that is unique to inequality. That one says that when you divide both sides by a negative number, when you divide both sides by a negative number, the inequality operation will reverse. When you divide both sides of equation of that involve inequality, when you divide both sides by a negative number, the inequality will reverse. For example, if I have 3x, let's say minus 3x greater than 12, and we are to find the value of x here. So if we are finding the value of x here, we have to divide by a negative number. That's minus that's minus 3x divided by minus 3 is greater than 12 divided by minus 3. So this, we cancel this one, I have x. So whenever you divide both sides by a negative number, the sign will reverse. The sign of inequality will reverse. So you have this one will become minus 4. So that is the second rules of inequality. Another example, for example, you have 6 minus 6x is greater than equals to minus 4x minus 4. So if I have this, so you have to solve this. To solve this one, I say minus 6x. If this one cross inequality sign, it become plus 4x. Then greater than equals to minus 4 minus 6. Minus 6x minus this one, I have minus 2x greater than equals to minus 10. Now, if I'm dividing both sides by inequality, so by negative number, I have minus 2x divided by minus 2. So the inequality will reverse. So you have minus 10 divided by minus 2. Right. So that's what I'm talking about here. So this, we cancel this one. Then you have s is less than equals to 5. So you can see that the inequality operation will reverse. If it's facing here before, it's going to face the other side of the inequality. So that's the second rule, and that's the most popular rule of inequality. Whenever you multiply both sides or you divide both sides by inequality operation, the inequality will reverse. So the inequality operation will reverse. And then Another rules of inequality before we solve other value, maybe in case they can test you on that, is that whenever you have a fraction, let's say 2x over 5 is less than 3 over 4, or let's say over 3, or let's say 4 over 3. When you have this and you take the inverse of both sides, if you take the inverse of both sides, you have this one give 5 over 2x. The inequality operation will also reverse. So this one will become 3 over 4. If you take the inverse of this one, you must also take the inverse of this one. Then just turn it upside down. Also turn this one upside down. As you turn the both sides upside down, the inequality operation will reverse. The inequality operation will reverse. So find the range of value of x and represent the answer in number line. So to solve this, these are simple inequality sign. If I have 1 minus 6x is greater than 5. So to solve this one, remember that the operation of a number is at the front of that number. Here with this 1, the operation is plus 1. The operation of 6x is minus 6x, not ordinary 6x. This one greater than 5. So if I must leave the one that has x here, so I'm going to leave it as minus 6x. So some students will just pick the 6x and leave the minus. So you have to go with minus 6x, as in go with the sign operation of that number. If it is negative, remember to write that negative. So it will be greater than 5. The one that we move to the other side is going to be minus 1, because minus 1 is positive, and when you cross this inequality sign, you have 1. So this one will give me minus 6x greater than, we'll subtract this one, give you 4. Now, the next thing is that you are going to divide both sides by a negative number. If you divide both sides by a negative number, what happened to the inequality operation? The inequality operation will reverse. So this one become minus 6x divided by minus 6. The inequality will reverse like this. You have 4 divided by minus 6. So this will happen. Then you can now continue your calculation. So this one will give me, this one cancel this. So I have x is less than 4 divided by this one, give me minus 2 over 3. Alright. So with this minus 3 over 2, I can represent this one in number line. So we should represent it on number line. When you're representing number on number line, so you draw, remember, let me use a very clear something that will be. So you draw a line. So I said this 0 is very important. The 0 is the point that will show you that will demarcate the positive line number and the negative line. So you see that minus 3 over 2 belongs to negative part. So you can write it here. It's just a sketch. Minus 2 over 3. Then on top of it, extend it further, you just put, because this number is strictly less than, there is no equality there. If it is a strictly less than number, and you see that x now is less at the lesser part, because this pointed part is the less. Whenever a number there, that number is less. X is less than this. So always read from here. Don't read from the number to the other side. Read from the unknown. X is less than this. If x is less than this, so that it will be easy for you, less will go to the right. Less will go to the left. Let me move to the left hand side. So the arrow will move to the end. So this is then you now put your x. So that will show that x is less than minus 2 over 3. So for this one, s plus 2 is greater than equals to 3. So to write this one, you see x is greater than 3 minus 2. So s is greater than 1. So if s is greater than 1, then you can draw your number line. Then you put 0. So the 0, like I said, is to tell you the part where you have positive and negative side. So this one is at the positive side. So we just put 1 here. Then you extend it. Then you put it. Because of what? This is as equality sign. It's less than or greater than 1. So I'm going to shade the something. And it's greater than 1. I'll go to the right side. So that's how to represent it on number line. So for this one also, we have 4x plus 20 is greater than 0. So this is 4x. So the 20 plus 20, which that has no s, we move to the other side to be plus. When you move to the other side, the sign of that 20 will change from plus to negative. That's minus 20. So you are dividing both sides by a positive number. That means 4x divided by 4 greater than minus 20 divided by 4. So that means s is greater than minus 5. So if s is greater than minus 5, so that's the answer. So to represent the number line, draw a number line, put your 0 here. So minus 5 is going to be here. So we put greater than, since proof is strictly greater than minus 5, is greater than, is going to move to the right. Greater than to move to the right. So the arrow here will move to the right, and you put your x. So the last one here is 3 minus x greater than equals to 1. 3. So to rewrite this one, I have to put the minus x. You see, anyone that has a negative, please remember to go with that negative. It's very important. Some students will just write s and they will not go along with that negative. 1, when these 3 cross inequality sign become minus 3. So we have minus s greater than equals to minus 2. And remember, we have minus, what we are looking for is x, not minus. Minus x. This minus s is the same thing as minus 1x greater than equals to minus 2. So that means I'm going to divide both sides by a negative number. So if I'm dividing by negative, that's minus x divided by minus 1. So the sign operation will change, then you have this minus 1. So to continue with, you can write it as, so just continue from here. So write that x now will be less than equals to 2. So this can be represented on number line like this. You can represent it on number line like this by putting this 0, then you put your 2 here, then so this is 2, because it's less than, it's going to the left, then you put your x. So this is how to represent, how to solve this question and represent them on number line. Right, so let's go to the next let's go to the next question. So the next question says solve the inequality and represent the result in number line. So to solve this one, you can see that the more you move along with this inequality along the slide, the harder the inequality is becoming, right? So in this one, you need to do some expansion. So to solve it, which is still very easy, so I believe you can do them. 7x is on its own. Some of you are using this 7s to multiply to open the bracket. 7s is separate. Any terms here is separated by operation. You can see that the negative is in between them. So you cannot use 7s to be opening this bracket. So it is 7x on its own. What is here now, here, that is a number that is here that is hidden, that you cannot see, is 1. So if you must put it, you must put 1 here. So 1 is a number, is a number that is always hidden, that whenever you say x, if I write x here, x is the same thing as 1x, right? And we can also say that x is the same thing as x raised to the power of 1. Some of you, when you see x and you say what is the coefficient of x, you say the coefficient of x is 0, because you can see that there are no number there. And the only number that is hidden, that's invisible, is 1. So if it can be invisible in power, some people will ask you, what is the power of this x? They say the power of this x is what? Is 0, because you believe there is nothing there. So the power of this one is only 1. It is only 1 that is 0. If it is going to be 0, they must indicate it. And anything raised to the power of 0 will be equals to 1. So it is only 1 that is invisible number. The only invisible number is 1 that you cannot see, that can be hidden and cannot be seen. So if you must put any number, you see, if you like here, see minus, and you want a number to open the bracket, by all means put 1. So that means minus 1 times this, they have minus 5x. Minus 1 times this one minus. Now that means it's going to be minus times minus is going to be plus. 1 times this, that's 3. So you are done with this operation and you have opened the bracket. Then you have greater than equals to 9. So this is how you open it. Don't use 7s, because a lot of error you'll be seeing students using 7s, far 7s, because of bracket. They are using the 7 to open the bracket. It's wrong. Alright. And if you must need a number, please put 1 to open the bracket. So this, by collecting like term, now collecting like term means the one that has x, put it on one side. The one that has no x, put it at the other side. So you can see that 7s minus this one has x. So I can put it together. So this is give me 2x. So I can write it as greater than, then 9. This one go to the other side, become plus 3. Then 2s is greater than equals to this minus this one, I have 6. So I have 2x divided by 2. 6 divided by 2. You can see that I did not reverse the operation. Why? Because I'm dividing by a positive number. You see that the operation still remains. Please don't ask me a question. Why don't I reverse the something? Because my rules only say that what? Whenever you divide by a negative number. So dividing both sides by 2, they are not negative number. It's not a negative number. So that's why my operations still remain the same. I hope I've answered that one. So this is x is what? Is greater than equals to 3. So with this, I can represent it on number line. So I represent it on number line. How to draw my line. Draw your line. So indicate your 0. 0 is very important to 0 to show the region that is positive and the region that is negative. So you see that 3 is at the positive side. So I can put it here. So we don't want to write all the numbers. Just the number that you need is only CD. So then you put it here. You put it. And because of equality sign here, I'm going to shade it. And if I read from X, S is greater, it's wider. Can you see now? The wider part is 15. That means S is greater than 3. Greater, and that's go to the right. Right? So you're no longer in primary school where you've seen using your left hand side, less than, your right hand elbow, greater than, less than, greater than, less than. No. So this, you have to expand that one. So wherever, if I read from the back here, S is 3 is less than, but always read from the unknown, like I said. So here, I also do this. So can also be solved as this, as 3x. So you are using plus 4 to open the bracket, that's plus 4x. This one, that's minus 12, greater than x minus 6. So if you collect your like term, so this one becomes 7x minus x here, greater than minus 6. Then this one goes to the other side, that's plus 12. So I have 6x greater than, so this one becomes 6. Divide both sides by negative number. So that means x is greater than 1. So you divide the number line. So this is your 1. So you thought, and it's greater, you go to the right. Right? Because strictly greater than. So I'm not going to show you the part that is. I think let's stop here and continue the next class. Thank you for to continue with next slide. I have another example, set of example where to solve the following inequality and represent the result on number line. All these examples are fractional, involve fractions. Whenever you get equations that involve fraction, the simple thing you will do is to find a way to express them to a linear equation so that they will be in linear form. Then to do that, we'll multiply through. You just multiply through by the LCM. Multiply everything by the LCM, and the LCM of this 4, 5, 2 is 20. So you multiply each concept by 20, so that you have 20 into 3 over 4x, then minus 20 into 4 over 5x, less than equals to 20 times 1 over 2. So with this 4 here into this, so we have 5 into 3x minus 5 here, 1, 5 here, 4. So we have 4 into 4x less than equals to 2 here, 1, 2 here, 10. 10 times 1, we have 10. So if you multiply through way, to give me 15x minus 16x less than equals to 10. So this will give me minus x less than equals to 10x. This minus x, like I said, is the same thing as minus 1x. So if you must find something to divide through, divide both sides by a negative number. That's minus 1x divided by minus 1 less than equals to 10. So now the operation the sign, you have to inverse the sign. Remember to invert the sign, because we are dividing both sides by a negative number. So that this one will be x greater than equals to minus 10. And if you're representing by on number line, so this, to write this, put 0. So here the negative number, that's minus 10. And on top here you put your, since something is greater than or equal to, you're going to shade it. And since something is greater, it's going to the right. So then you put your value of x here. So this has to represent it on number line. So also this can also be solved like that. So to solve this, since we have a single fraction here and under the other side is single fraction, you can also multiply through by the LCM, like we said, like we did here, or you cross multiply. So whichever one that is applicable, that you like, can do it like that. You can multiply through by LCM. Multiply through by LCM. So you don't need to write this in, just for you to understand what I'm saying. So you multiply through by LCM. The LCM is 10. LCM of 2 and 5 is 10. So I'll multiply this one by 10. 5 minus 3x over 2 greater than equals to 10 again. 2x plus 3 divided by 5. So you close it so that This one become 5 into 5 minus 3x. Then greater than equals to this 5 here. Cancel this one. Cancel this one, I have 5. So that's why this one cancel this one, I have 2. So then 2 into 2x plus 3. So if I open the bracket with this what I've like this will give me 25. 5 times 5 25. 5 times minus 3, that's minus 15x. So greater than equals to 2 times this, that's 4x. 2 times this, that's plus 6. 2 times 3, that's plus 6. Alright, then I have to collect like terms. Those numbers that with like terms. If I'm collecting like term, I'm putting those number that has negative number at one side, the one that has no negative, the one that has x, if that has variable x, put it to one side. The one that has no variable x, put it to the other side. That's minus 15x. So this one has variable x, cross equality sign to this one, minus 4x. So it's greater than equals to 6. Then this to the other side become minus 25. Alright, with this, we add this one give me minus 19x greater than equals to. So if you subtract this one will also give me minus 19. Now I'm dividing both sides by minus 19. So both sides by minus 19, that's minus 19x divided by minus 19. So the sign will reverse. I mean the operations inequality will reverse. It's minus 19 divided by minus 9. So that this one will give me x is less than 1. So, and this can be represented using a number line. Let me put it here, the number line. So the number line here is this. So this one, sorry, I'm representing it here. So that using number line. So the number line, since I have the positive number, so the positive number I can represent it here as 1. So on top here, so if something is strictly, sorry, not strictly, it's less than or equals to. So less than or equals to, it will move to the arrowhead, go to the left. Since something is less than or equals to 1. So that is the solution to that. The next slide, you see the same fraction. So solve the inequality and represent your answer in number line. Still the same. So we do that. That's will give me since I have a fraction here, 1 over 2 into bracket of 3x. So let me clean this. Sorry. Into bracket of into bracket of 3x minus 2 greater than equals to x minus 6. So in this, I'm multiplying through by okay. So here the only fraction here is 1 over 2, and that shows that the LCM, if this one is over 1. So the LCM here 2 and 1, the LCM is 2. So I'm multiplying through by this one by 2. That means 2 times 1 over 2 into bracket of 3x minus 2 greater than 2 times x minus 6. So multiply through that, this cancels this one. I have 3x minus 2 greater than equals to 2x minus 12. So that this is 3x by collecting like term. This will move to the other side as minus 2x greater than equals to minus 12. That's minus 12 will be left here. When this one cross equality sign become plus 2. So if you subtract this one, you have 1x, which is 3x minus 2x. You are left with 1x, or we call s 1s, or we can leave it as x, right? So 1s is something like I want you to get used to, where a time where you say 1s is something as x. So greater than or equals to minus 10. So this is our solution. So to represent it on number line, so you can represent it on number line. Just put the okay. Then here you put 0. Then this minus 10 is at the negative side, which you can call minus 10. Then on top of it, then you can put your 0, and x is greater. The wider part is facing it. S is greater. S is greater to go to the right. The arrow will go to the right. So you put your s, but greater than and equals to. So I'm going to shade it. Greater than or equals to, you shade it. That's something like that. All right. Let's still go for more solution on this one. Let's go to this one. With this solution, I hope you'll be able to master all the different form of inequality in this one. So this is fractional one, how to deal with fractional one, how to deal with this, the one that has expansion, the one that has a bracket, how to open the bracket. This one has to do with fraction, how to return to linear. Then from the linear, then you now collect like term and solve. So the same thing, this one is a fractional, and what I say, anything that has fraction, you multiply through by the LCM. So you will multiply through by the LCM. And the LCM of 371, see, LCM of 371 will be 21. So it's going to be 21 into bracket of y plus 8 over 3 over 3. LCM, we did. LCM is a primary knowledge. It's a primary prerequisite knowledge from primary. So if you don't know how to calculate LCM, so you can learn from somewhere. That's say 21. Also, we to multiply 2y minus 4 over 7. Then less than equals to 20. Sorry, it's literally less than. There's no equality sign. Pretty less than 21 times 1. So I multiply each term here by the LCM. This term by the LCM. This one by the LCM. This one by the LCM. So this cancel this. So I have 7 into y plus 8 left minus this one cancel this. So this one give me 3 left, 2y minus 4. So less than 21 times 1 to give me 21. So if I open the brackets, so give me 7y. This is 7 times 8 give me 56. 56 minus 3 times this, that is 6y. Plus 3 times minus 4, let me give me plus 12. Less than 21. That's plus 3 minus 7 plus times plus minus times minus, you give me plus. So if you collect like term with this, remember your inequality is here. So you collect like term, this one will give me 7y minus 6y less than 21. 21 is other side of inequality, so 12 is meeting it. That's minus 12, yes. So another something that's meeting is what is minus 56. Alright, so if I subtract this one will give me y. Yeah, that's 7y minus 6y, give me 1y, that's y. Less than 21 minus this. 21 minus 12. That is 11. Yeah, to give me 10 minus this, that's 2 minus, that's 9. 9 minus 56, that's 47. That's minus 47. That's minus 47. So to represent it on number line, so you have to get your, let's get this. So on number line, draw your line, then put your 0, that's to demarcate positive and negative side. Then minus 47 is negative number, so I can represent it at this side. Minus 47. So represent this one. Less than, we go to the left. So this one is y. Sorry, represent it as y. So let me clean this on the right. That's y. This y. Alright. The next slide is still fractional something. This is an exercise for you. What you do is just to multiply through by the LCM. Multiply through by the LCM 2, 4, 6. They are all factor of 12. If they are factor of 12, it means that what 12 is their LCM. So the LCM here is going to be what 12. So the LCM is equals to 12. So if you multiply each of them by the LCM, if I multiply this one by 12, that means 12 times s over 2 plus 12 times 3 over 4 less than equals to 12 times 5x over 6 minus 12 times 7 over 12. So that's how to go about it. So this one times 12, this one will give me 6, that's 2 here, that's 6, 6 times 8, that's 6x. 4 here, 1, 4 in this one, that's 3, 3 times 3, that's 9, plus 9. Less than equals to 6 here in this one, that's That's 2 times that's 10x. 12 into this, that will be minus 7. That's, sorry, -7. Sorry, oh, that's -7. Alright. So that to collect like 10, I have 6x. The one that has x here is that -10x less than equals to -7. It's already here at the other side. Then this one will cross, so this is -9. It's +9 here. When it crosses inequality sign, it becomes -9. So when you subtract this, you give -4x less than equals to -16. So I'm dividing both sides by a negative number. That's -4x divided by -4. So the inequality will reverse. Minus divided by -4. So that this become x is greater than equals to 4. And if x is greater than equals to 4, so represent it on number line. Let's think of number line. So let's represent this one on number line with this. So you draw, sorry, this. Okay, let me try it on. Let's draw it as simple as small here. Draw your line. Then you put your 0. That 0 is very important to show the positive and negative. Then 4 is positive, you put it at the other side of the positive side. Then you extend it up, then put 0. So because it's greater than or equal, that equality sign, I'm going to show this part. Greater than, the wider part is facing it, that's greater than 4. That's greater, we go to the right. So this is it. So you put your x. Alright, that's how to represent it. This one is very simple. So see, yeah, this is example of where you apply the fourth rule of inequality. Can you see? If you look at this, I can cross multiply, but if I want to express it so that the number which is I can easily find the LCM should come down. So what happened? Do you know that this one, that fourth rule is applicable here? I can write this number as z plus 2 divided by 7. So you see, I inverse this one. So if I immediately inverse this one, the sign operation is going to reverse. You see, so I will also inverse this one. You see that is applicable to this one. Can you see now? So with this, I can easily use the LCM now to be -14, so that to clear it to the top. You see, that's where you apply the fourth rule. Or another way, you can cross multiply. You can also cross multiply to solve for your z. So this one is z. Remember, it's z. So if the LCM is equals to -14, it's -14 that is LCM. 7 can go in there, -2 can also go in -14. So if I multiply 2 by -14, that means -14. So we multiply this one, that's z plus 2 divided by 7. Then less than -14, we also this now, that's -14. Then open the bracket, that's 5 minus 4z over -2. Let's close the bracket. So that's 7. We go with this. So let me use something will be easy for you to see that 7. We cancel this, so that I have -2 left there into z plus 2 less than this. We cancel this, negative, we cancel negative, then 2 we cancel that, that's 7. Call that one, that is 5 minus 4z. So with this, I can open my bracket, -2z. This one times this, that's -4. Less than 7 times this, that's 35. 7 times this, that's -28z. 7 times 4, that's -28z. So that if I collect my like term, by collecting like term, I have -2z. If this one cross inequality sign to the other side, it becomes +28z less than. Now, it's now. Okay, so this will give me 35, which is 35. So it's here before. Then this -4 cross will become +4. So if I subtract this, they give me -26. Sorry, plus 26z, because plus is bigger than negative here. So less than, you add this one, give me 39. So z is equals less than 39 over 26. So this is what you get. 39 over 26 is approximately 1 point something. And to draw it on number line, it's very simple. Draw it on number line. You just write your number line, draw number line. Just sort of put your 0 here. That's to show you the demarcation between. Since 39 divided by 27 is something approximately 1 point something. So let's say, assuming it's here, 39 over 26. Just write it. So put your 0. And it's strictly less than. There's no equality sign. So it is less than. It will go to the left. The arrow here will go to the left. And you put your arrow. And you put X. Alright. That's the solution to that. So in lots assignments, I would like everyone to answer this one, although this one involves brackets. See the same process with used in the other two. This is Y question, and you see that it's a Y question assignment. Solve the inequality and present them on number line. So, but I'm going to attempt them, and you see how you go about the solution. So let's see how we go about the solution. So this one is 3. All right, sorry. Alright, so I have 3 into 2x plus 1 greater than equals to 1 over 3 into 2x minus 9. So with this, you see that this is the only fraction that I have here, which is 1 over 3. In that case, I can multiply by LCM. The LCM will be 3. So this one is over 1. So you should multiply through by the LCM, which is equals to 3. So you use 3 to multiply this on that. If I use 3 to multiply this, so it's going to be 3 into the 3 that is there before, 2x. So I'm multiplying through by the 2x plus 1. Right? That's greater than. This one is also be 3 times 1 over 3, then 2x minus 9. So 3 times 3, that's 9 into 2x plus 1. Then you close it, greater than. So this 3 cancel this. So 1 left with 1. 1 times the other one, I have 2x minus 9. So I can open the bracket here, that's 18x. This one times this, that's 9. Greater than equals to 2x minus 9. So if I collect like term, I give me 18x minus 22x greater than equals to minus 9 is here. When this one cross equality sign, we also become minus 9. It's a plus 9 here. When it crosses, it becomes equality. So subtract this one, they give me 16x is greater than equals to minus 18. I'm dividing both sides by positive number, 16x divided by 16. So the operation will not reverse because it's a positive number minus 16. So that s will be greater than minus 18 over 16. So I can write that therefore s is greater than equals to minus 9. That's 2 here, then over 8, which is about minus 1 point something. So it is 1 point value. So I can represent it on inequality. Just put the, so this 0. So let's assume it's a negative number. I put my minus 9 over 8 here. So then shade it. Then greater than, you go come to the right and you represent it like this. So that's just how to represent it on inequality. The same thing is also applicable to this one. I can write this equation of this one. Since I have some mixed fraction, why don't you write that mixed fraction in improper fraction? So by turning everything to 1 plus this to improper fraction, 1 over 1 over 2 to give me 3 over 2 x. So greater than equals to this to improper fraction, give me 5 over 3 x. minus, to the proper fraction, give me 7 over 6 over 1. So the LCM of 2, 3, 6 is 6. So I'm multiplying each term by 6. So I multiply this one by 6, and it's 6x, plus multiply this one by 6. So I multiply this one by 6. So this one will be, that's 6. Cancel them. 6 times 6 divided by 2, that's 3. So give me 9x. So greater than equals to, if I multiply this one by 6, multiply this one by, put 6 here, that's 3 here, that's 6, that's 2, 2 times, that's 10x. Then minus, multiply this one by 6, so will be 7. So you collect like them. This one is already 6, and that's 15x. Then collect like that's minus 10x, greater than equals to minus 7. So that this one will be 5x, greater than equals to minus 7. So I divide both sides by 5, by 5, by 5. So s is greater than equals to minus 7 over 5. So by representing it on number line, so it's 0. So minus 7 over 5 will be here, which is approximately 1 point something. Then put your value there, greater than or equals to, when it be shaded. The shaded greater than, go to the right. So you put your value of x. So that's for that. I think so we stop here for the simple linear inequality. So we continue from here to combine inequality, the next class. Thank you.